All right, this will be our last video for 14.3, which means something else. So let's look at the graph, and we're going to use this big old graph to evaluate all of these limits and function values. Okay, so the limit as x approaches -2 from just the left side. So you're tracing in on the curve until you get to x equals -2, which would be here. What y value does it look like you're going to run into or hit? 3. So that's your answer. Now part B wants to know what it is when you approach -2 from the right. So you're going to approach it from the right. So you kind of trace over, and if you have to jump across, skip over stuff, do it. You don't stop tracing until you get to that x value. So some people, they trace and they go, what do I do? We'll just hop down and keep going. Don't stop until you get to x equals -2. And once you get there, then look at what y value you are approaching. So you're approaching 1. So that's your answer. Now part C wants to know the limit as x approaches -2 from both sides. Well, look at what you did here. The left is 3, the right is 1. They're different. Well, if they're different, then the limit does not exist. All right, so that's that's how you do a one-sided limit from the left and the right. So let's keep going. Now D just says, hey, what's the function value when x is -2? So now you're looking for wherever the point is when x is -2, and it's right there. So that y value is a 1. Okay, part E, as x approaches a -1, it's a two-sided limit. So you're tracing until you get to x equals -1, and they do not look like they are approaching the same value. They're different. The left is 1, the right is 0. So that is D and E, does not exist. Okay, part F, we're going to approach 0 from the right. So trace over until you get to x equals 0, and it looks like you're going to run into y equals -1. Now it wants to know the function value when x is 0. So when x is 0, where's your point? Well, it's not here where the hole is. It's where you have a solid dot or point. So that's way up here at the 4. All right, let's keep going. So the limit is x approaches 1 from the left. So you come to 1, and it looks like you're approaching y is equal to 0. And let's see, on this one for part I, when you approach 1 from the right, you're coming in here, and what trips people up is they're like, oh my gosh, there's an open circle, I better jump down on the point. No. Like, you don't care if it's an open circle or close, just what is it that you approach? So if this is open or close, it's not going to change what you do. So you're still approaching y is equal to +1. So for the two-sided limit, you just came up with two different values, one from the left, one from the right. So the limit does not exist. All right, when x approaches 4 from both sides, so from the left, it's -2. From the right, it's also -2. So the overall limit is -2. Now the function value when x is 4, there's your point, and it's right on y is equal to -2. And then the last example lists all the discontinuities of f. So wherever f has like a hole or asymptote or gap, so that would be at -2 because there's a big old gap. -1, x equals 0, because now there's just a hole. And the last one is that x is equal to 1. So those 4 x values are your discontinuities. Okay, that is going to do it for section 14.3, and that is the last section of the entire class. So it's been fun making videos with you guys. I had a lot of fun when we were actually in class. I would have preferred that to go all the way through, but it is what it is. So if you guys have any questions, let me know. Hope to see you guys on campus in the fall or the summer. And yeah, just let me know if you have any questions.